So now we're going to start our panel discussion. I'm going to seed it with a few pre-prepared remarks and questions, and then I'll open it up to all of your questions. So I think we all talked about the role of utilities and what the grid means for electric vehicles. But it's really important, so I'd like to drill down a little bit in this discussion. So Greg, do you want to give us your perspective on that and what role charging management software has to play?
Absolutely, happy to. So good afternoon, everyone. My name is Greg. I'm heading the expansion of the Mobility House here in the US. Mobility House is a 10-year-old technology and operations company. We are headquartered in Munich, but have offices in Silicon Valley and in Austin, Texas. And our focus is on EV charging, technology for EV charging, and vehicle grid integration. And we can talk more about what that exactly means. But to your question, Ed, on what's the impact of electric vehicles on the grid? What's the impact on the utility? And what can we use in terms of technology to manage or mitigate that impact? One of the things that we've been learning is a lot of fleets, when they approach electrification and transitioning to electric vehicles, they focus very much on the vehicle itself. What type of vehicle do I need to purchase? And think very little about what does that mean in terms of the infrastructure that I need to put in, and how do I manage the infrastructure in such a way that I actually get to all of the savings in operational costs. We've seen a lot of the statistics that operational costs of electric vehicles is lower than for ICE vehicles. That's true, generally speaking, but unfortunately there are many examples, in particular in the fleet space, where because the charging portion isn't managed well, we see that the costs are actually higher. So a famous example is in Denver, the Transit Authority there electrified, and they were shocked by the amount of demand charges that they were seeing when they actually put the fleet in operation. So important is that you do upfront analysis on what does the electrification of your fleet mean. What does it, and what kind of technologies can you apply to mitigate those demand charges? And one good example is in Europe, we had, I think you had airport, Schiphol Airport in the Netherlands as an example out there for electrification. It's one of the largest electric vehicle fleets. They're deploying our solution, Charge Pilot. That's the platform that we've built to manage electric vehicle charging. And through that, they were able to drastically reduce the amount of power on site they need, and they're saving hundreds of thousands of dollars per year because they need less power on site, and they can charge and manage the charging such that it is mitigating the overall demand. So. Yeah, I'll let you take it from here. And
Great.
So I wanted to just quickly add from our experience in Orlando that most utilities, electric utilities that are very interested in the EV space, right? They see it as the saving grace for their business model. Utilities are in the game of selling kilowatt hours. And what we're beginning to see is, because of efficiency standards and because of building codes improving and just overall energy efficiency, even though we're growing in population, we've been pretty much stagnant in terms of growth of electric vehicle demand or electricity demand for decades. And this may be the tipping point for them to get into it. So it's funny how the electric utilities are now almost competing with the fossil fuel oil and gas industry to see who can win out in transportation. And we're going to see that more and more. And so in my experience, engaging utilities on this notion of electrification is something that they are open and willing to discuss and talk about because they see it as part of their saving grace to keep their business model operating.
Mm-hmm. And Joffrey, maybe you can talk about Mortenson's experience interacting with utilities when you're building these projects that you mentioned.
Yeah, there's two types of interactions on the energy and infrastructure side of Mortenson, our customer tends to be energy developers, independent power producers, or utilities. So I'll use the example of Excel since they're in Minneapolis, like we are. As they look to move towards 100% renewable energy, they're going to want more solar, more wind. They'll look at things like battery storage. And they may hire Mortenson to design and build, or they may work through a developer. So our interaction with utilities is very consistent on the energy and infrastructure side and working through the interconnection processes. It also applies, though, when you talk about the commercial construction side of Mortenson. So if you're talking about building a stadium or a building that has significant load, we're coordinating with the utility to make sure we can get enough power to the facility.
Maybe just to build on that, I think figuring out, can you get the power that you need is one question. The other piece is at what cost, and then finally what period of time. In California right now with the wildfires, the utilities have been pushing back schedules on getting power to customers. So we've had customers that want to electrify their fleet, but they're waiting on the utility to put in a new transformer or a new interconnection. So really engaging the utility upfront is one of the most important elements as you transition to electric vehicles.
Yeah, there's a very long lead time for what those folks do and the upgrades they have to make, right? So that has to go into your planning. Absolutely. So looking a little bit further into the future with the grid, could we speak maybe to vehicle to grid or V2X applications in all of your views?
I think Greg's probably the SME on this one.
Great. I'll start with Greg.
Absolutely, happy to. I think the notion of vehicle grid integration is one that more and more people are becoming aware of and interested in, because it is becoming clear that as we transition to electric vehicles, we're going to have a ton of batteries on wheels that are not going to be in use for 80 to 90% of their time. So what that means, there's a lot of lost economic potential, because we could use those batteries to provide different services to the grid. And that's important because if we're transitioning the grid to renewables, we'll need a lot more flexibility to balance out that volatility of wind and solar. When the sun doesn't shine and the wind doesn't blow, we need to have some way of storing the energy, and that could be electric vehicles, and those batteries could be much cheaper than having dedicated batteries, dedicated energy storage to provide that service to the grid. What we tell customers is the technology is there. What you are waiting on right now is the technology to get cheaper, and number two, regulation to evolve. That then allows for the interconnection of electric vehicles with the grid, and sort of that bidirectional interplay, feeding power back into the grid. But what you should think about right now, even if it's not possible yet in many places, is that you put in the infrastructure and the software that allows you to do that in the future. So if you transition your your fleet, always talk to your infrastructure and software providers about whether they have technology that will enable you to later participate with your vehicles in vehicle-to-grid services.
Now, Chris, you mentioned, well, speaking of...
We have one audience question there, or two.
Yeah, absolutely.
So I haven't worked for electric utility. So on that, what do you actually believe that customers would be willing to give up the electric capacity of their batteries to a utility that may need to draw on that?
Yeah, I think it really depends on the customer.
And the value that the customer is going to get
Exactly.
for that.
Yeah.
That's really what it depends on.
So for us, the way we think about this is today, obviously nobody wants to have their vehicle or their battery their mobility needs compromised by providing some sort of service to the utility. But especially if we're talking about fleets and there being a monetary incentive to provide those services, there will certainly be customers who are interested to generate revenues with their vehicles, especially, and that for us is the main the way we think about building the technology is the mobility needs to be secured first and foremost. You need to know as a vehicle driver, as a fleet owner, my vehicles at 7 a.m., if I need them at 7 a.m., are going to be charged. That's number one priority. And we just make sure that we use that time during which they aren't in use and optimize how the battery is being used. But in the end, your vehicle is ready to go when you need it to be ready to go.
What compensation are customers being provided in Europe where you're seeing and implementing bidirectional charging? How are they incentivized today?
Yeah. So in Europe, we have a number of the different deployments. Most of them are still in the pilot stage, but the way we're incentivizing customers is for instance, in Amsterdam at the stadium, at the soccer stadium, you as a visitor get premium parking if you provide your vehicle's battery as a backup service to the stadium while you're attending an event. That could be one mechanism. That's sort of a creative one. But there will be all kinds of different business models evolving in the future to compensate customers for energy services.
And building off of the business model, I mean, most of us are aware of demand-side management that utilities provide, demand response systems, right, where they can kind of control certain assets within your facility or your home, whether it's turning off hot water heaters or, moving set points for your HVAC system. And in doing that, you get credit on your bill for that. It's kind of a swap. It's almost like net metering for rooftop solar, right? You're getting this bill credit. It is a one-to-one retail rate. We probably won't see one-to-one retail rate for you to give power from your car. Maybe we will in the beginning. But the other thing that we really have to figure out, and this is more on the automaker side, is how to not void the warranty of your battery by doing that. And at this point in time, to my knowledge, there isn't a single automaker, including Nissan, who happens to be at the forefront of this type of work, that is allowing bidirectional charging without voiding that warranty. And I may be wrong, Greg, you might know more about that, but we've been looking into it. And that's one of the barriers of us really going all into this at this point in time. But we are realizing that it's coming faster than we can keep up with. And the next chargers that we're looking to deploy, as we saw at the Fleet and Facilities Complex, will be bidirectional ready. And they will have the technology and hopefully the software to allow that once we get the okay from the manufacturer that you're not going to void that warranty on your battery.
Now, Chris, you spoke about the utility here in Orlando pioneering this battery as a service business model. So that's great in terms of increasing adoption of electric buses, right? But the ability to do that, is that somewhat of an artifact of this being a municipally owned utility? How does the regulatory question come into play here with other utilities maybe trying to replicate this?
It's a good question, and I think something that we're still exploring. I think the utilities are still exploring. They're realizing that that is a significant revenue model for them as we move forward. But there is some regulatory challenges, at the state of Florida Public Service Commission level, how to, these are regulated utilities, really have to scrutinize the base rate that they're providing to their customer base. And so there's a lot of that concern. Municipal utilities, again, have a little bit of autonomy from the Public Service Commission to a certain extent, and we can think differently about these models. And so we're really trying to pursue some unique aspects. Battery as a service is one of them. The charging as a service is another. But now we're actually looking at energy efficiency as a service for commercial and multifamily markets, where we can go in and do deep retrofits with no upfront cost and repay over the bill. So I think it's imperative that we start to change our mindset away from we're just selling kilowatt hours to we're selling services that can support this transformation and keep us relevant, right? I think utilities are going to stay relevant. We need to keep them relevant. And in our case, we need them to stay relevant because they give the city a substantial amount of revenue to keep our taxes low and our services high.
And that that model somewhat reflects a broader shift to as a service type
Correct.
models in
Mobility as a
many of
service
other
even,
industries,
right?
right? Absolutely.
Being one of those.
So it's all sort of in line. Do we have a question here?
Hello, everyone. I'm Larissa. I'm from Brazil. So I have a question for Chris, because from a national level, a national perspective, in Brazil we have the power generation 62% coming from hydroelectrics. Yes. And for me, it's kind of paradoxical that in the United States you have so many utilities and working with generation distribution. But you still have, you mentioned the competition between the fossil fuels industry and also the utility companies and providers. How do you think we could address the sustainable point of view of the emissions on the power generation in the States? Because in the end, we are talking about the electric vehicles in the consumer part. But what about the generation?
The
If the
supply side.
generation is extremely polluting, it's kind of controversial.
Sure. The tailpipe to smokestack argument, right? We hear a lot about,
Absolutely.
right? You're replacing your tailpipe emissions to the smokestack emissions. There are several studies showing that there's even considerable savings in emissions by doing that, even though we're still fossil fueled. But there's also the other added benefits, especially in communities, where you see an improvement of air pollution because you have less particulates, less NOx, SOx, and other emissions in the core of where people are and further out. Your question was, how do we address this transformation from the utility and at the national level? And if you're asking me personally, which I think you are, this is off record from City of Orlando's stance, but I will say that I think that utilities use the atmosphere as a free sewer today. And I believe that in order for us to transform at the pace and depth that we need to in order to meet the scientific community's targets and maintain quality of life on this planet as we know it, that we need to put a price on the externality. We have to really start to get serious about that being part of the economic equation. And the second you start to put a price on that externality, you begin to change the paradigm of investments, of where you see now Larry Fink from BlackRock coming out saying that core part of their investments moving forward will be climate and sustainability. And these investment models are now starting to pivot. And so I think that we really need to take the responsibility of putting a price on carbon. And how you do that, I think, is the question. I think that there's interesting models around this fee and dividend idea, essentially, pricing at the well site or wherever the raw material is being extracted, and then essentially providing a dividend based on that revenue back to every taxpayer in America monthly. So it's an additional revenue that you get as a taxpayer to help mitigate the impacts that plant has on public health and on the environment that we depend upon. And that paradigm in thinking is, in my opinion, the way that we're going to get there.
I have one build, and maybe at liberty to say a little bit more since I don't work for a city. I think that where you see the most aggressive changes taking place, it is because there are mandates that are being put in place by states or utility commissions, and then you're seeing decisions on generation and the IRP process, which we were talking about differently. There are different outcomes that are taking place. So I think that we can't ignore the fact that policy plays a big role. Utilities have a business model, and they're going to try and work that business model. But if there's policy that's supporting a shift in generation, I think you see different outcomes taking place.
This is really where all of these technological questions that we've been talking about collide with the political
How to get
ones.
there, right? The political
Right.
ones, exactly.
Yes.
How to accelerate.
It's a super multidimensional. I think we had another question in the back. We have two.
I have a two-part question. One of them is that I understand when you have people that live here and they charge cars mostly at night, that you can use the overnight charging, utilization of batteries, and it won't be a problem. But what about tourists? Like, I come from Atlanta, I would drive, and since it takes a while to charge the car, I would probably do it at lunch. And with proliferation of the electric cars, there might be 1,000 people stopping at lunch trying to charge their cars. There won't be that many chargers around at these. How are you going to handle that? Wouldn't it be better to standardize on battery size and do it like with propane tanks? Pull up the gas station and pull one out and push the other one in.
Yeah, battery swap models. And there are some examples of that being explored. Better Place is one of them back in the day, a few years ago, that was considering that model, and I think has gone belly up since. But overall, I think we have to think innovatively about that, and I do think that that's probably going to play a role into the future. I will say that in our experience, 90% of the charging in the vehicles that we have in Orlando happen at home and at work. Okay. At home and at work. And so that's why our focus is workplace charging, is really trying to ensure that we have the adequate infrastructure for those individuals to be able to charge in those times. And to your infrastructure point, I think that's the conundrum that we're in to figure out how to get there, and why I think a utility business model like what we're testing here could potentially be the way to get there. The upfront investment for any business is always going to be the barrier. They don't want to make that investment. There's a risk there. Is it going to be utilized enough for me to get a return? There's a lot of questions. But if we can come in and land it, and over time charge incrementally on your utility bill, it becomes a wash essentially, and it allows them to be empowered to add that infrastructure. So that's kind of our goal, and it's been working well. As mentioned, we're close to almost 400 level 2 chargers and level 3 chargers here locally, and we're going to add another 100. And so we're hoping, and that's not even enough, I'll tell you the truth. So we're hoping to continue that rollout.
I think that the technologies will get better, and there will be longer ranges on some of the vehicles, which will be able to help. The other thing, though, that I think is important is there's a gap that exists in infrastructure, and is it a question of the infrastructure will come once there are enough vehicles, or you need the vehicles and then the infrastructure will follow? I don't know which comes first, but one of the things we think is going to happen in the future is more shared infrastructure. So capital perhaps owning large EV charging hubs where folks from the public or non-public are able to come in and charge vehicles for a fee. So there's a gap that's going to be in place for some period of time, but I think there'll be unique business models and charging configurations to close the gaps that exist.
Right. New models to follow those needs as they emerge. Right. And to speak on the battery swap issue just for a second, that is a concept that has really taken off in Asia, but mostly for small vehicles, for 2- and 3-wheelers that have these sort of small modular batteries. But if you think about a full-size electric sedan or SUV, the batteries are large, and they're really designed in to the vehicle architecture itself. So it's really hard to make it sort of modular, and you can swap in and out. But people are exploring it, and there is a use case for it. Please.
Yeah, so my name is Ton de Vries. I'm from Bentley Systems. I have a question for Chris, and it's not so much on the technology or the financial programs, but it's more like, how do you engage your whole communities and get this out there and get that spark in that community to really adopt all these EVs and the programs you have? Because I mean, the technology is there and it's evolving. It's great, moving forward, but you need to get the public with you, right? If you want to reach those goals, then it's not only for the happy few and the people who buy the $70,000, $80,000 Teslas, but you know, people who buy a
$30,000 vehicle,
$40,000 vehicle.
Yep, 30 to 40,000.
They need to swap over.
Yeah, this is a really interesting question, and a lot of cities that I collaborate with, we're all testing different ways to get our communities excited, right, about EVs in general. One of the great initiatives that we do quarterly here is an EV ride and drive event. We essentially bring out dealers who have electric vehicles. We set up at our stadium, huge flat lots, and we allow people to just go at it and test these different types of vehicles. And hundreds of people come out per ride and drive event, and it really starts to get the interest going, because there's nothing like sitting behind an EV and actually driving it. You can hear about it all day, but the second you get into it, light bulb goes off. Now I get why people are enthusiasts for EVs, right? Now I get it. In fact, who here has not driven an EV with the raise of a hand? All right, so we have some enthusiasts. Okay, so a couple people, it's worth it. Maybe next time you use the Drive Electric Orlando effort, and you could try it. So that's another one, Drive Electric Orlando, the partnership with our rental car community and trying to make sure that they, one, have the fleet available to offer EVs, and then two, what are the perks that we can provide you to get into the EV and start to create these collaborations. So in the city, we went out to the Hotel and Lodging Association of Central Florida and said, hey, we want to roll this program out. You have all the hotels and the lodging institutions. Can you start adding chargers? And we'll help you offset some of that cost. We went to the airport. We went to the theme parks and made sure that they had infrastructure too. So we certainly have to make it fun and exciting. The last point I will make, and I just talked to an EV enthusiast last week. He's a local guy in Orlando, and I hadn't ever met him. And he mentioned an anecdotal point that has stuck with me, and that is that people are right now in this chasm between choosing the EV for their primary vehicle versus their secondary vehicle. We're in this movement where people are in their secondary vehicle and they feel confident with it as an electric, but not so much confident as the primary. And my question was why? We have all this charging infrastructure. We have 400 chargers. Like, is it the charging? And he thought that basically, one, the DC fast charging network isn't available enough, isn't adequate enough to get people away from the range anxiety. And it isn't the local range anxiety. We got that locked in. It's the one trip that I make from here to Atlanta to make sure that I can actually get there without a nightmare, right? And so even if I don't go to that Atlanta trip this year, I'm buying the vehicle thinking, my primary thinking, that I'm gonna take that on a potential road trip, going to Miami or going to Atlanta, and it may be a nightmare for me. I'm gonna choose this SUV and I'll get an EV for my local commute or my second car. And I think we're in this chasm. And we're at this point in the next 1 to 2 years where if we can start to really help identify that DC fast charger infrastructure, I think we're going to start to see more of the adoption accelerate even further.
Maybe one more point to talk about community engagement. How can we get communities, and in particular low-income and disadvantaged communities, get engaged here? So one of the things that we're seeing in California is a lot of funding is actually dedicated specifically to help low-income communities and disadvantaged communities transition their vehicles, whether it's county vehicles or school buses, to electric vehicles. And so we were working, for instance, with a number of schools and helping them get electric school buses transition to become zero-emission school districts. And part of those engagements is usually working with the students and the teachers and the maintenance shop on educating them on the benefits of electric vehicles. And that's a great way how you can go and and make sure that that benefit is shared across society.
The last point I will make, that, and we're not doing it, but some cities, I think Indianapolis is doing it and a few others, they have a car share program that's electric. I think it's called Indigo. And their car share program allows the city to utilize those vehicles when they need to send a permitting technician to go out into the field. But then it's also utilized for low-income communities, subsidized, for them to use in their own vehicle commutes. And so you have this shared, back to the mobility as a service, you have this shared asset that is both a community asset and a city asset that we can essentially share together. And that might be a model that we will see more of. We're exploring it here in Orlando, and we're trying to see if that's possible.
I'm up next. Chris, I walked in a little late, but maybe you answered this. You know, I keep on seeing the cost points of electric school buses being so dramatic. So, at what point, what are the obstacles to the city of Orlando to converting to 100% electric school buses?
Well, there are many, and all of us have talked about some of the challenges, whether it's infrastructure, whether it's the actual business model. We don't manage the public school system, so it's a separately governed institution. We work very closely with them, but I don't manage their fleet. And but there is a lot of interest, especially because of the amount of dwell time that essentially school buses have. They're sitting longer than the traditional vehicle sits, and we sit maybe 80 to 90% of the time of that vehicle's life is parked, right, and on a regular vehicle. So you can think about school buses have even more dwell time than that, but we're talking about massive fleets as well, thousands and thousands of buses. Some of the charging, scheduling, it looks like Mobility House can provide a lot of that type of service. We need for us to really figure out how to do that at scale. We could do it with little pilots, but at scale
That's
it's a
in the
challenge.
macro sense, and perhaps I led with that, but I have the same concern that are we going to reach an obstacle point where if I and my 4 neighbors that are on the same transformer all decide to buy electric vehicles, well, we all can't charge at the same time.
I don't think
And that's essentially the same problem you have with the 400 school buses. That there's a arguably significant to extremely significant upgrade that needs to be made.
Yeah, I mean, I just upgraded my home and added a level 2 charger, and was surprised at how simple that was. I was thinking I was going to have to trickle charge my car forever. It's really a 40 amp breaker in your panel and a connector to a NEBA socket. I mean, it's actually more simple at the residential level, and so I don't necessarily. And I think the utility is obviously looking at planning in terms of their substation, transformer, infrastructure, switchboards, etc.
Well, I know that earlier on, I had worked on some dynamic pricing models so that you'd be bidding against your 4 neighbors that are citizens of that one transformer. But that hasn't really evolved to, where it's a doable proposition. It's not so much buying the commodity charger for your home. It's the idea that, okay, someone needs to change something on the pole, the transformer, because the load of a car is arguably equivalent to that of a whole house. And I live in Boca, so my air conditioning's running.
So there are no,
2 cars on one transformer at a time. So you have to schedule them out.
Where are you?
Oh, sorry.
Which
As a power distributor, we can't handle more than 2 cars charging at a time on an individual transformer. So we need to have some sort of ability to schedule that out, as you were alluding to. Else you have to overbuild your infrastructure. It'd be just way too expensive.
exactly. I think there are many studies that show that the build out of infrastructure will be incredibly expensive if we don't invest in smart infrastructure. If we have the ability, if we provide the utility, the ability to manage the charging, to control when and how much.
Stagger them.
Exactly, when and how much vehicles charge, that will end up with dramatic cost savings. So there's some case studies. One is pretty famous from Hamburg, where they did an analysis on a bunch of their transformers, and it would have cost them $20 million to upgrade their grid to provide for 70% electric vehicle penetration, and only $2 million to invest in smart infrastructure. And so obviously, if we have to push for putting in smart infrastructure such that utilities won't be having to deal with these issues in the future.
It's such a case of work smarter, not harder. Right? We have one question in the front.
Just a question for Chris. I think Orlando has about 300 transit buses, give or take. Just wondered, I know you mentioned you had tested 5 different buses. Have you made any decisions about which one worked best in this climate, and how you might be phasing in electrifying the fleet and the impact on the utility infrastructure for where you have your bus yards?
Yes, good question. So we've tested Gillig, New Flyer, BYD, Proterra, and I believe, what's that 5th one? Nova. I think you're right. It is the Nova bus out of Canada. So those are the 5. We tested all 5 of them within our downtown BRT, which is a protected limo lane, and over a 2-week period to identify charge capacities, to look at the user experience, et cetera. Based on that, the transit operators had a say in what bus they preferred. They ended up preferring the Proterra bus over the other 4 manufacturers. And so we just recently went after the Lono grant that's offered by the US DOT, and were awarded $2 million this past year to start us on this journey. We had already purchased a few EV buses, but now we'll add an additional 8 this year into that system. And simultaneously, we are having the utility and transit in the city work together on infrastructure improvements at their operations center, where the charging will occur. And so we're in the process of doing an engineering study to identify the best ways to manage the charging. The cool thing about the BRT specifically is that the bus travels the furthest line in the BRT travels 94 miles a day. So when you're looking at these buses now in the 200 to 300 mile per range, I think that it's suitable enough for us to potentially even trickle charge throughout the day with level 3 DC fast charging and not have a substantial grid impact at night when all of them essentially are being plugged in. So we're looking at potential in-route charging, whether it's induction, whether it's overhead, or just traditional plug-in at the operations at our Link Central station, which is where all the buses go back to at a certain point. So we're still kind of looking through it, but we're pretty excited about the rollout and this new kind of business model, seeing if it works financially for everyone.
Wow. We had a question on the right.
Yeah, just a follow-up question on the infrastructure on the grid. What is there any strategic plan at national level to look at upgrading any infrastructure required for the expected growth in electric vehicle charging, not just the local charging infrastructure, but power stations, distribution networks, etc.
Jeff, do you know?
This is from other conferences that I've attended. I know that the different ISOs have done analysis in terms of potential impact. And at a transmission level, for the foreseeable future, there aren't significant challenges that I'm aware of. The significant challenges come into play with respect to what we were talking about in the distribution system. The example this gentleman just talked about in terms of each transformer can only accommodate so many vehicles. So from a high level perspective, I think from a transmission standpoint, we're okay. It's the distribution side where we anticipate very significant challenges. And I'm not adding a lot of color, but it's kind of out of my area of expertise.
And that's at early levels of adoption. Of course, as adoption increases, the challenges will broaden out to transmission as well.
A question for the gentleman who's part of the utility. Back to you real quick. I'm interested in this notion of 2 cars per transformer, because I've never heard of that.
Well,
And
it depends on the
light.
rating of the transformer. So the
rating of the transformer, and also the actual amperage of and voltage of the charging, right? So you probably can have multiple cars on a level 1.
I'm just talking about the energy consumption and rough numbers, yeah. So I don't have the details with me.
Okay.
Yeah, the cable capacity, yeah. Just so in our typical residential neighborhood, what we've rated our transformers at, we figure we could handle two cars charging at the same time on a transformer.
2 cars charging at what capacity, though? That's the real question. Because if they're trickle charging overnight over a 10-hour period, and they're literally a level 1, 120 out the wall, right? That's just like plugging in an appliance, right? It's not and you can have hundreds of potential cars that way. If you're talking about a level 2, 220, 240, right? That's different. Now you're talking washer and dryer type loads. And then level 3, which you don't really see at the home.
Yeah, we're talking the higher loads.
So you're talking level 2 or level 3 or both?
I don't know. The engineers were just mentioning this.
Mm-hmm.
But I think it's
But
for 2 cars.
I think
Level
to
3,
level 3.
add on to the technical question, I don't think you can see it as an individual issue with just EV charging. You have to combine it with your level of penetration with distributed energy resources and solar and wind and wherever energy is generated, because it might
balance itself.
balances it out. Yeah, right. So it's a more complex, let's say, answer to a broader question.
And that's
You know,
where
how does our energy mix look like in the near future, and how are we getting there from a distribution perspective?
and that's where the software and the management
Yes.
are so
Yes.
so key.
Yeah.
Go ahead.
Just a comment. I love the elegance of buying an electric vehicle and charging at a low rate at night and then selling power at 3 p.m. and having a free ride. Okay. However, we have a colleague that would like to do that, and unfortunately, the discharge cycle count and the warranty of your battery allows you to not do anything like that whatsoever.
Yeah, we just
Yep.
like to mention it. Yeah, we briefly mentioned vehicle battery warranties, and that's something we're still working with manufacturers about. They're concerned about the bidirectional and the wear and tear on that battery system, and their, of course, guarantee of performance for the car that you bought. And
Yeah.
so there's some things to work through.
We might have to see a shift from a warranty based on miles or years to actual charge cycles, and then you as the consumer decide, does that charge cycling, is that worth your value? How much compensation are you receiving? And then you do that calculation, or your software more likely does the calculation.
Yeah, other models, some of the OEMs currently are talking about it, are thinking about what can I give customers or aggregators, charge management companies like us, in terms of parameters of how they can use the battery for things other than driving. So that it could be that, it could be that in the future an OEM says, okay, you can use the car obviously for driving, and then you can use up to 50 cycles per year for other things. Or you can, do V2G as long as you stay within a state of charge of 35% to 75%. So that's all things every single OEM is thinking about and is working with us, because we obviously have a ton of experience in vehicle grid integration and using batteries and bidirectional systems, and they know that that's a potential revenue stream in the future for customers, and they see this as if they are first as an OEM to provide that as a competitive advantage, especially in the fleet space. If I can give my customer a vehicle that can generate up to $1,000 per vehicle per year for me in the energy market, that's going to bring down my TCO. And that's going to be a competitive advantage for whoever comes out and figures that out first.
So they'll start competing on the parameters of their warranty on the battery as well.
Or your ability to
Right.
discharge, or your, exactly.
Rich countries, right? Because I can imagine the grid in Brazil, for example, when we have blackouts still, why not to sell? Why limit it to sell the energy from the electric fleet? It's like the whole integrated grid.
The concept of virtual grid, right?
On one side you can surplus in the other side.
One in the back.
Is there a standard on charges as far as voltages and currents for different cars? Or so can any car use any charger, or there's different, like does Porsche use the same charger as a Mustang, or?
No, so that's still an issue the industry is working through. There are a few main charging standards out there. So there's the CHAdeMO that the Asian OEMs use. There's the standard North American and European, and then Tesla has its own. And now China has developed one of its own.
Well, and that's DC fast charging. There is a standard for level 2, the J1772 charger. That's the standard for most of the level 2s.
Right. So level 2 is what you would use in your own home, right? 90% of the time, 90 plus, in your garage, in your driveway at work. When you're on the road and now you're thinking, can I use that plug? Can I use that plug? Can I not? That's where these 4 that I mentioned come in.
Is there any way through GPS you can tell ahead of time where there is a free charger that nobody's using?
Yeah, there are lots of apps that sort of aggregate that information in detail for you. but the industry is moving somewhat towards consolidation and towards giving you different adapters from Tesla to another standard or vice versa. But it's still a little bit piecemeal.
And the actual electrical spec is pretty standard across those different levels as well. There is some level 2 now looking at increasing the amperage that it is capable of pushing. Right now it's usually a 40 amp breaker that allows, but they are talking about 80 amp breaker level 2 chargers, J1772, so it gets you almost to a level 3, but you're still using the standard that everybody uses around the world, right? Not as fast, but it's faster. And I think we're going to start to see more of these EVSE companies, the supply equipment companies, start to incorporate kind of the level 2 plus before you get to the level 3. It's going to be much cheaper to do, less utility infrastructure to land. So there's some pros, there's some cons, but there's some pros to it too. In the very back.
I wonder. I think Orlando has an interesting opportunity, given that you have a municipal utility, your transit agency is run by the city, and then the Department of Sustainability. Mm-hmm. So I wonder if you're kind of flipping this whole conversation on its head and saying, where do I have available capacity from an energy perspective, and how can I match transportation planning around available capacity on the power side? Is there are you thinking about things in that perspective? Or?
Our transportation planning organization is called MetroPlan. We do have several initiatives going with them to really look at regional charging infrastructure, not just here, but the three county core, what we call tri-county. And so there's a lot of that conversation going. We are energy rich in Orlando. We actually export power to the Florida Municipal Power Agency's power pool for other municipal utilities. So we tend to be in a different situation, and even in that respect, where we're not too concerned about peak demand and oversupply. We are now trying to figure out how do we retire some of those legacy assets and quickly transition them to renewables and storage, and even looking at demand side management a lot more as a first fuel, whereas right now I think we're just scratching the surface with efficiency and demand response. I think we've got to go a lot deeper if we're truly going to transition. And so there's a lot of conversation. We now have 100% AMI metering for both electric and water across our entire territory. So we have the foundational element. We have a meter data management system that is now allowing enhanced tiered rate structures and some of these capabilities that, again, are all foundational to allowing these very unique models that we're talking about. So I think in the next few years, we may see some exciting things come out.
Any more questions? All right. There was about one or two I wanted to get to. Do we have time here? Nope, that's about it. We've had a really good panel, excellent presentation. So I want to thank our speakers and panelists today. This was wonderful. Thanks, man.